This lesson is on accuracy and precision and their measurement. First off, definitions. Accuracy is an indication of how close a measurement is to the accepted or actual value, and precision is an indication of how reproducible a particular measurement is. We can use a target to illustrate the difference between accuracy and precision. If a certain archer stands up and shoots an arrow, he hits here, he is inaccurate. He has not hit the intended target. If a second archer shoots here, he is more accurate, but he still not has hit the intended target. If a third archer comes up and he hits the bullseye, then he is accurate because he has hit the intended target. So again, accuracy is how close you come to the accepted value or actual value. Precision is how reproducible measurement is. And so if 4 archers come up and each hit these, none of these are reproducible. Every archer has hit a different spot. No 2 arrows have hit the same spot. And so the different measurements are not precise, and only one of them is accurate. If 4 archers come up and the first one hits here, the second one hits here, third one hits here, fourth one hits here, then that is very precise because they are all hitting the same spot. However, they are still not accurate because they are not hitting the bullseye of the target. If 4 archers shoot in a separate set and the first archer hits here, second archer hits here, third archer hits here, fourth archer hits here, then they are both accurate and precise. Accurate because they're all hitting the target, and precise because they are all hitting the same spot. So accuracy really refers to how close each measurement is to the accepted value. Precision, how reproducible. How many times can the archer hit the same spot? How many times can the person making the measurement make the same measurement? So let's look at a data set for a series of measurements by 4 different students, and where we know the accepted value is 12.23. So student 1 gets 12.22, student 2 12.44, and so on. So if I asked you which is the most accurate of all these measurements, then it is going to be student 1 because student 1 comes closest to the accepted value. And if we comment on precision, I would say the precision is fairly poor because here we have 0.22, here we have 0.44, 0.11, 0.88. So they're fairly spread out. They're not getting the same measurement over and over again. If we got 12.22, 12.23, 12.21, 12.21, then we'd say they are fairly precise because all the measurements are very similar to each other. So again, accuracy and precision are different things. Okay, let's look at these 2 data sets. Here we have data set 1, data set 2. If we look at the average of these 2 data sets, they come out to be the same. And so if the accepted value was actually 5.50 meters, we would have to say they are both equally accurate when we look at just the averages because they are the same. But if we were to say which one is more precise, now we don't want to look at just the average, we want to look at all the measurements. And I would have to say that data set 2 is more precise because if we look at all the numbers, they are much more similar to each other. And here the numbers are more spread out from each other, so data set 2 is more precise. So how do we think about this? Here we have 2 sets of measurements. One certainly seems better than the other, but if we only report their averages, we're going to report them both as 5.5. And so scientists must have a way to indicate the precision of a set of measurements to indicate how precise, how reproducible were those sets of measurements. Okay, go through a couple sample problems here. We're going to first calculate what is called error. Error is a measure of accuracy. Again, accuracy and precision are 2 different things. You measure accuracy with error. You measure precision with deviation. So a Tecumseh High School student determined the mass of 1 mole of carbon found to be 12.2 12.021 grams and the actual value is 12.011 grams, we want to determine the absolute error and the relative error of these measurements. The equation for absolute error, it's the absolute difference, meaning always positive, never negative, between the accepted and the observed values. So absolute error equals the absolute value of the difference between the observed and the accepted values. So here is the observed value, here is the accepted value, and so the absolute error simply is the difference between the observed and the accepted. So the observed minus the accepted gives you the absolute error. How much did he miss the target by? How much was he off? The relative error is simply the absolute error divided by the accepted value times 100%. So now we want to know how big is that absolute error compared to the accepted value. Is it a large part of it? Is it a small part of it? So here's the calculation for relative error. Here is the absolute error. Here's the accepted value. So we take the absolute error, divide by accepted value, multiply by 100%. So it is 0.083%. In other words, he is only 0.083% wrong. If you were taking a test and you got only 0.083% wrong, that means you would be, what, 99.917% correct. And so he was very close to the accepted value. Okay, I do like you to put all your answers in boxes. That way I know what your intended answer to be. And so if you would get in the habit of that, I would appreciate that. Okay, let's look at a sample problem for precision. Again, now we're not talking about how close we are to the accepted value. Now we want to know how reproducible a particular set of measurements is. And so let's say the same student measured the mass of a sample of magnesium sulfate 3 times and he gets 3 different numbers, 5.01 grams, 5.03 grams, and 4.98 grams. The first thing I would suggest to you is make a list. Here's his 3 measurements, 5.01, 5.03, and 4.98. And the first thing you want to do is find the average of those measurements. So this is something you probably have done before. If you get different numbers for a particular thing, the best thing to do is take the average, but we're not going to stop there this time. And the next thing I want you to do is find the absolute deviation. The absolute deviation is the difference between each of his measurements, the first, second, and third, and the average of those measurements. So the first one is 5.01. And the average is 5.01, and so the absolute deviation is 0. The second measurement is 5.03, and the average is 5.01. That differs by 0.02 grams. And then the third measurement is 4.98, and the average is 5.01. We subtract the 2, and we get 0.03. Again, notice the absolute difference between each measurement and the average measurement, and so that is the absolute deviation for the third. And then we want to take an average of those numbers. So we take an average of the measurements, and we take an average of all the deviations, and then the final answer is expressed as the average measurement plus or minus the average deviation. So the average measurement plus or minus the average deviation. That average deviation is called the uncertainty. That's how much we don't know the answer. It really could be 0.02 grams higher or 0.02 grams lower than that 5.01. And that indicates the precision of the measurement. And again, I'd like you to box in your answers to indicate the final answer. One last thing. If we go back to this data set of measurements, if we had actually calculated the average deviations, then data set 1 would have a greater average deviation or a greater uncertainty because its numbers are less precise. But again, if you will report only the average, it doesn't tell you that. And so that is the purpose of calculating the absolute deviation. The average deviations are what we call the uncertainty of the measurement. That ends this lesson.